Hi, my name is Tom Gehring. This video is dedicated to the Miniature Engineering and Craftsmanship Museum located in Carlsbad, California, and is intended to introduce and explain the model crane and its various attributes to the museum staff in preparation for my donation of this model to the museum. The model comes with this model crane owner's manual that contains a wealth of operational and maintenance information as outlined in its table of contents. While the manual includes less operationally pertinent information such as how to transport the model crane, it contains all of the information contained in this video. Additionally, included in the manual is a flash drive with all of the digital files relating to the crane, including the bill of materials, all of the sketches, and over 2,700 photographs. The model crane alone weighs just over 85 pounds, so I've designed this removable lifting harness that attaches to a structural member located at the model's fore and aft center of gravity. Whenever the model is to be lifted, it's important to first fore and aft balance the model and cable attached accessories with the boom lowered to just 2 feet above grade. Secure any of the model's cable attached implements, such as in this case, the 5-pound clamshell bucket, to the top of the counterweight. After balancing the model with 2 staff, one on either side of the model, each holding the model's lifting bar by the black vinyl taped ends, shown here temporarily supported by my overhead crane, hook each of the left and right lifting bar chains to the harness's forward-facing eye hooks, and then the model will be ready to be lifted and transported wherever staff desires. This is a zoomed-in view of the model's centrally located 3/8-inch square lifting member. Here is a closer look at the lifting harness's steel lip that hooks under the model's centrally located 3/8-inch square lifting member. Note that the lip does the lifting while the threaded rods, when screwed in place, serve merely to hold the lip in place under the lifting member. Sorry for the confusing terminology, as in the documentation this device is referenced as the lifting bar. But since I've recently added a true lifting bar to the support equipment inventory, I've referenced this device in this video as the lifting harness. And this now is referenced in this video as the model's lifting bar. I previously emailed the museum information on lithium polymer batteries and their support equipment that I've included in a 2-page document, the cover of which is shown here, and the information of which is shown on the back of this covered container. It's complete with reference QR codes to various sites to help understand how to use this equipment should staff not be familiar with it. Also included in the container is the manual for the DX8 Gen 2 transmitter and its corresponding charger. I've got the backup battery in here because the primary battery is currently located inside the model crane. For the purpose of clarity, I took this photo to illustrate how I recorded the following 2 video clips by placing my tablet under the model's overhung counterweight that houses the LiPo battery compartment. Looking at the underside of the model's counterweight replication, you see the hinged battery cover with its latch. Rotating the latch to the open position enables the battery hatch cover to swing open, allowing access to this single in-service LiPo battery. Using a Velcro hook pad adhered to the upper face of the battery compartment and Velcro loop pads attached to each battery to lightly hold the battery in place in the compartment. Note that I also used orange shoelace loop to enable me to pull the battery out from the compartment, exposing the plug. When plugging and unplugging the battery, be sure to just pull on the battery connectors, not on the cord, like so. Similarly, when replacing the battery with a new battery, plug it in and then replace the battery up into the compartment, being sure to stuff all of this surplus cords into the compartment before closing the lid. Also under the cab, immediately forward of the hatch cover, is the 3-position power on-off switch. The off position is the center position. The left side position turns the model power on and also turns on the Droke battery meter to display the battery charge, amps drawn, and other battery information in the right rear window of the model's cab. The right side on position turns the model's power on, but without turning on the Droke meter. Note that the lit cab lights indicate that the battery is turned on. Here you can see both the rear lights illuminated and the Droke meter in the rear right window of the cab. Let me show you how the emergency shutdown system works. Here we have the dragline fair lead. Should the fair lead be drawn in too far, it will trip this micro switch here, which shuts the power off to the entire model. And I'll show you shortly how to restore the power, but when the power is restored, the fair lead can be returned to normal operation. Similarly, should the boom be raised too far, this switch over here will similarly cut off all power to the model, and using the same technique as with the fair lead override, the boom can be lowered and power can be resumed to the model. Note that adjacent to the antenna to the cab's primary receiver is an indicator light notifying the operator whenever the emergency cutoff has been activated. These two zoomed-in photos show both the fair lead and boom movement limit switches. Located behind the operator's station are a series of switches both on the front face and the side face that control lights and the cooling fan motor. However, when you have the power cut off because either the boom is raised too high or the drag line is pulled in too far, the way to override that would be to press this red button here, hold it in while you lower the boom and or unreel the drag line, and then you can restore power. Here is a better view of the cab switch panel. The 3 side-facing toggle switches control lighting, and the top forward-facing switches turn on or off the electronic speed control cooling fan that should remain on, and the telemetry receiver. As previously explained, the bottom forward-facing red-capped momentary switch is pressed to override the power cutoff relay. Current radio control systems are comprised of transmitters and receivers to control RC models. Pictured here is a Spectrum brand DX8 transmitter with one primary receiver and its mated satellite receiver, similar to the RC system I selected. In the case of the model Crane, however, I chose to use 3 receivers that are located throughout the model. The primary receiver for the model's endlessly rotating cab is located here, with its linked satellite receiver located here at the back of the cab. The lower crawler assembly's primary receiver is located here on the front side of the crawler bridge, with its linked satellite receiver located here on the rear side of the crawler bridge. These linked satellite receivers are particularly important to this model as it is made with a lot of metal components. I later added a third receiver that is located within the cab just under this right rear cab window to provide telemetry information on the charge status of the battery that can be observed on the transmitter's screen. As illustrated here by merely rolling the thumbwheel switch to the right of the transmitter's screen. Also note that the transmitter is currently programmed to initiate a verbal warning whenever the model's LiPo battery charge goes down to 10.5 volts, even though the recommended safe minimum battery charge level is 10 volts. Currently used 2.4 gigahertz RC equipment require receivers to be binded to transmitters. So should a changeover to a new transmitter ever be required, all three receivers will need to be accessed in order to insert one of these three binding plugs into each of the three receivers in order to simultaneously bind the three receivers to any new transmitter. This is the Spectrum DX8 Gen 2 transmitter that controls the model's operation. The owner's manual for the transmitter and the transmitter's charging cord will be provided in the LiPo battery and support equipment container. The manual explains how to charge the transmitter's battery. The transmitter's on-off switch is located centrally here on the transmitter with the off position to the left and the on position to the right. Be sure to turn the transmitter on first to allow it to boot up before turning on the model. Note that when the transmitter is turned on, the display screen shows the model, the transmitter battery charge in the upper right-hand corner, and the timer displaying the transmitter's on time. The left stick controls the left and right rotation of the cab by moving it to the left and the right. The up and down movement of the stick is designed to control the throttle on RC model aircraft. However, on the model crane, it controls nothing and should be left in the down position. On the upper left corner of the transmitter, there is a three-position switch, C, that controls the left tread movement, where the upward 0 position is forward, the center or 1 position is stop, and the downward or 2 position is reverse. Note that the rear of the lower crawler assembly is the end where both the left and right crawler tread chain drives are located, so going forward would be moving the lower crawler assembly towards the end that does not have the chain drive. Also on the upper left is the three-position switch B that turns the sound system on or off by repeatedly moving the switch lever back and forth between the 0 and 2 positions. The upper left three-position switch D controls the boom hoist drive with the forward 0 position lowering the boom, and the central 1 position is the boom hold position. The rearward number 2 position raises the boom. On the right-hand side, the R knob controls the RPM on the sound system. Turning it clockwise increases the RPM, and counterclockwise reduces the RPM. The three-position switch F, located in the upper right-hand corner of the transmitter, controls the right tread movement in the same manner that switch C controls the left tread movement. The right stick controls both the upper and lower drum hoist motors and is a bit tricky to get used to operating. The good news is that both control sticks are programmed for exponential movement, meaning that stick movements close to the center result in slow movement responses, and movements to the outer range of the stick movement represent faster model responses. Moving the right stick upward reels out the cable on the upper drum, and moving the right stick downward reels the cable onto the upper drum. Similarly, moving the right stick to the left reels the cable onto the lower drum, and moving the right stick to the right reels out the cable on the lower drum. It takes a bit of practice to get used to this dual control scheme. particularly with the clamshell setup, as when hauling up the closed bucket, the open bucket line also needs to be reeled in with some level of tension, and hence the chain is attached to the open bucket line to provide that little bit of required chain tension to the line that otherwise would be slack. Here's a photograph of that chain that provides tension to the open bucket line when the closed clamshell bucket line is hoisting the bucket. Note that the right hand stick can simultaneously operate both drums by movement anywhere in the 360-degree zone of operation, and that is where some level of right stick time practice may be required. Note that there are 2 trim tabs for each of the 2 sticks that are used basically for model aircraft operations and are not really required for use with regards to the crane. There are several copies of this page of the owner's manual in the inside cover of the owner's manual that's being provided to the museum for use by each of staff members to get familiar with the various stick functions on the transmitter. Since operating the model crane can often involve getting down on your hands and knees to tend to some aspect of the model, I decided to design and fabricate this pictured transmitter holder that enables me to mount a transmitter in front of me with both a neck strap and a belt strap that would keep it from dangling around as I tended to the model. Since the accidental flipping of either the boom hoist switch D or the left or right tread movement switches C and F would not be desirable, I designed and fabricated 2 spring-loaded tread switch covers that can be pushed up and rotated outward as shown in this photo, exposing these switches whenever the tread motors require operation. Also note that the left switch cover has a slot machined into it that allows for the focused use of one's fingertip to operate the longer boom operation switch D lever whenever the left switch cover is in place over the left tread switch C. One final note regarding the transmitter. I will be delivering to the museum this original box that the transmitter was delivered in, along with its custom molded protective dunnage, should any issue arise that would require the transmitter to be mailed back to Spectrum's U.S. distributor, Horizon Hobbies, who are located in Illinois, for repair. Since the museum may want to periodically change out the model's display, I will be providing the model complete with all of the various clamshell bucket, dragline bucket, and 6-part block/cannonball hook setup accessories that are included in each of the videos that are shown on my YouTube website at Crane Model Build 3236. Note that it is preferred to display the model in any of its configurations for long periods with lifted loads set at rest, as bent memory of weighted lines around the various shivs could possibly result with hanging weighted loads for extended periods. While the extended 9-foot boom may be too large for display at the museum, nevertheless, the 3-foot boom extension to the standard 6-foot boom will be provided along with the boom extension's wire boom support cables. The company Nets and More, located in Louisiana, supplied the model's size 36 rosary twine cabling. Cutting the twine with the scissor can result in unraveled ends that makes threading the line through the model's various shiv sets very difficult. I have found that cutting the twine on a hard surface with a sharp X-Acto blade provides the cleanest cut with minimal unraveling. I also have found that sealing the tip of a cut line or temporary line splice only for the purpose of pulling a new line through a set of shivs, such as the clamshell bucket, is best accomplished as illustrated using a third-hand fixture, 1 small drop of medium gap-filling CA glue that does not wick along the cable, and a shot of glue-setting accelerator, sanding smooth any resultant glue blobs. The key goal is to provide a flexible splice or termination that can be pulled through the shiv sets and subsequently cut off as new line is terminated. Changing out the clamshell bucket, for example, I would recommend cutting the closing bucket line with the bucket in the closed position about 8 to 10 inches above the bucket before sealing the line ends and storing the bucket for later use. Here is the clamshell bucket with the closing bucket line termination knot cover removed, and how the termination knot would pull a newly spliced line through the bucket sheave set. Note the 4-sheave block in this video was reeved using all 4 sheaves, resulting in an 8-part line. I would recommend, however, to reeve the block as a 4-part line setup using the 2 outer sheaves as shown in my channel's Sacramento RC Fest video. Following are comments regarding boom tip changeovers. When reinstalling the multi-sheave block hook, land the figure-8 knotted end of the block's upper reel line into the cavity of this boom tip receiver. To relocate the cannonball hook's lower reel line from the left of the 4 primary sheaves, first detach the line from the cannonball hook as shown here. Next, unscrew the boom tip's 4 primary sheaves left side spacer by unscrewing the 256 button head cap screw with a 0.05-inch hex driver. Here is the removed left side spacer to the boom tip 4 sheave assembly. The 4 boom tip sheaves' outer diameters run intentionally close to the boom tip end plate and thereby help to hold the lines captive to whichever sheave they are set to run in. The cannonball hook's line, however, can be carefully walked over its containment by holding it to the left while rotating the sheave, while also being careful not to exert any undue force on the boom. An alternate plan would be to uncotter key the shaft and carefully move it slightly to the right to allow for the line's removal. The cannonball hook's clevisted line end can now be removed from the 4 sheave boom tip assembly. The cannonball line can now be installed to run on the extended boom tip sheave by undoing one of the boom tip extension shaft's cotter pins, removing the shaft and sheave, and reinstalling it with the line in place on the sheave and under the extension's retention bar. The clamshell bucket's tagline rewinder uses 2 No. 3 EPDM rubber bands that can apply torque to the rewinder reel as set by carefully pulling out and turning the reel's opposite end cap as shown here. I made 2 sizes of timber swap mats that are typically placed under crawler cranes. When I displayed the model at public events, however, I locked the 2 larger mats together with these 2 magnetically held connector bars, each with 2 leveling screws, to level the corners of the combined swamp mats. I will be providing the model with this toolbox that contains various tools that are used in tending to the model, starting with a paintbrush that I use to dust it off. Also provided is an assortment of open, closed end and Allen wrenches mounted to a tool holder for easy access. I made this model crane screw organizer for use in cataloging the various screw sizes and lengths whenever it may be required to remove one or all of the cab panels. Note here, for example, how the 4 front left cab bottom 440 button head cap screws on the model circled in red would be stored in the red circled front left holes of the organizer. Similarly, the 3 rear blue circled cab bottom screws are stored in the blue circled holes in the organizer, and so on. Included in the box is a folded gantry holdback fixture that I use as a temporary replacement for the gantry backstay bars whenever removal of the rear cab section is required, replacing it with the backstays after the rear cab section has been removed. This tooling package was used to convert the 4 VW chassis grounded windshield wiper motors I used on the model to wire grounded motors as detailed in sketch number 112. Lastly, while I used number 36 rosary twine for all of the model's cabling, I have this full spool of number 24 rosary twine that could be used as an adequate substitute should any of the 3 drums of cable need to be completely replaced. Here's a brief video of the model crane and all of the equipment I plan on delivering to the museum on Saturday, June 20th. Obviously the crane, it's set up with the lifting harness. Notice I have the extra 3-foot boom section attached to the cart. Also I have the lifting bar and the harness I use to lift the crane with my overhead hoist. Going down here we have the box, the owner's manual, the flipping fixture, the dragline bucket on a display stand, toolbox, extra spool of rosemary twine, various information required for the sale of the flash drives. Notice I have the boom set up on a tripod just to relieve the tension in the extended position on the hoisting cable. I even including the rocks I used in the video. Here you see the various fixtures I'm going to be providing the museum to do with as they want. And I have all the documentation, including the original A and B size drawings in the blue box, and all the A size drawings rolled up in this long box. Here's the tub with the various equipment for battery charging and recharging. Here's the scratch-built 30-foot scale trailer, and also have a dump attachment for that trailer and an attachment to carry the 10-pound twin lead screw aluminum auger that I use to lift to the top of this stand that I made using the first boom section I made out of soldered aluminum. And then of course all of the various components of my swamp mat system that I created for the crane. So anyway, that's just a tour of it. Please feel free at any time to contact me after delivery with any questions you may have. I'd be more than happy to discuss that with you. Thank you.